Let's discuss continuity. A function y is equal to f of x is continuous at x is equal to c if these three following rules hold true. So there are three rules. The first one is that f of c exists. So that's pretty simple and basic. But the second one is that the limit as x approaches c of f of x also exists. So this means that the left-handed limit and the right-handed limit have to equal. So that means the limit of x approaches c from the left of f of x must equal the limit as x approaches c from the right of f of x. And the third rule is that the limit as x approaches c of f of x equals f of c. So this means that if you plug in a number, if this x here approaches c, the value that it approaches has to equal f of c. So let's see how this holds true in different scenarios. So let's say we have a graph, right? And it looks something like this. And this is, let's say, positive 2, this is negative 2, and that's 0. And this is 2. So this graph here, is this function as a whole continuous? Alright, and that's one more thing. That if all these three things hold true at every single point, then the entire function y is equal to f of x is continuous. So if at every point c, if these three if these three rules hold true, then the whole function is continuous. So is this function continuous? Well, if we look here, the f of c, does it exist? So let's just take a point like 2. This seems to be the only problematic point right here. So f of c exists because f of 2 is equal to 2. That point there. Does the limit of f of 2 as x approaches 2 exist? Let's see. X approaches 2, f of x. This has to mean that the limit from both sides has to be the same, right? From the right and from the left. And when we see it approach from the left, it's negative 2, and we see the limit approach from the right, it's 2. So right here, this function is not continuous. Let's take another example. Let's say we have something that looks like this. And it has a discontinuity here. Again, the function exists at this point, but and the limit, actually, this is slightly different from the example we did before, because the limit here exists, let's say this point is 5. So limit 5 from the left and limit as x approaches 5 from the right of both of these things, of this function f of x, is actually the same from both sides. It's the same point. But there's a third rule. The limit as x approaches c of f of x has to equal f of c. And in this case, the point f of 5 is actually 0. And the actual point is not. So this function is also not continuous. That's it.